I'm not looking at what you guys are writing. I'm just going to be surprised by it. But make sure you're writing in your questions. What questions do you guys have? There's a link there. Yes, there's a link for questions. Try not to write over each other's questions, obviously. I'll stop it at 10. Good morning, those of you that are joining us. Please go to today's lesson, find the questions, the link to questions, and put your questions about the lab on that document. I will stop at 10. I only have time for 10. Good morning. Good morning, beautiful people. Good morning, beautiful people.
Good morning.
Find the document for questions and post your questions on there. I'll look at them at 8:45. Beautiful song. All right, I'm going to go in there. Let's see what we've got from you guys. So we have, we still have a few minutes to get to write them in. But yes, I had people like, hey, what's up with don't we have the quiz? And I was like, no, we missed last class. So the quiz isn't until next Monday. So, and a lot of you guys, you know, you were trying to do this experiment like yesterday, the day before. You still have time, man. This is the easiest experiment that you will do all year. It's not tough. This is simple. Take an hour and a half from the time you start cutting potatoes till you're done. It's really not that difficult to get done. So we've got plenty of time. Let's see what questions did you guys have. Oh, Keaton, you got a new hat? You got rid of the shark?
Oh yeah, I have plenty of hats. Like this one was from Mr. Linegar.
Mr. Leonard.
He also gave me a Conquistador's hat and a Knight's hat, but it doesn't. The Knight's hat is too small. I just gave it to Ellis.
Okay. I don't know what that hat is. What is that?
It's supposed to be like one of those caps that like people flying airplanes would wear in like World War II and such.
Yeah, my grandmother flew in World War II. My grandmother was literally a pilot in World War II. Can you believe that? She did not fly for the Army, but she ferried airplanes from the West Coast, where they manufactured them in Seattle, to the East Coast, where they would ship them to the European theater. How old do you think she was? I'll tell you right now, she's 92. So count back. She did this in 1944. She's 92. She'll be 93 in December.
So she was like 20, like less than 20?
Yeah, she was a teenager. She was
Wow.
Really almost y'all's age. Imagine that. That's crazy. Okay, it is 8:45. This is 5 minutes later. So let's take a look and see what we have. There's a chat. Okay, thank you for that, George. I appreciate that. And I'm recording it so you can check it out later. So first questions first, and we have an agenda, so I'm setting alarms so make sure that we give this the full attention that it deserves. And so we got 15 minutes to go over this series of questions that you guys have. It says, I watched the video, but I'm not 100% you went over it. I watched the video, but I'm not 100% you went over it. How do we keep the mass of the potatoes the same as the mass? Oh my gosh, this is a really good question. So how do we keep mass constant? You can't. That's going to be very, very difficult to do. That is a very good question. So when you watch me put those potatoes in there, what was I actually measuring when I put the potatoes into the water? What was my dependent variable? Because I couldn't keep the mass the same. So what did I use instead? What did I use, not instead, but how did I measure that, the change? The expansion, I actually didn't measure the expansion. You could, and I think that most of you guys probably should, but what was I doing in terms of their measurement? I was measuring, you may not actually know because I haven't put that in Excel yet, you've seen it. But what I was doing is I was measuring the percent change. So I wasn't measuring, because that's a really good question. I don't know who wrote that question, but that's a really good question. It's if mass is going to be, if I see something gained, like if I was looking at a gain of mass of 2 grams between something that's 100 grams and something that was 50 grams, well, it's 2% for something that's 100 grams, and it's going to be I guess 4% if it's 50 grams. That's not very good. I can keep it I'm trying to keep it as close as possible because I'm cutting them all exactly the same size. But because I am using percent change in mass, I kind of get rid of some of that that variability in the difference in terms of their mass. So if I cut the center out of a potato, it might be actually a little different in the mass than the edge of the potato. So you're not going to be able to control for that, having each of those the same mass. There's just no way to do it. I mean, I guess you could possibly do it by taking out a little bit of the core of the potato or something, but that's going to start changing the density of the potato too. That would be really a big problem. I wouldn't try to even worry about controlling for mass. And whose question was that? So I can make sure that I've answered your question.
It was my question.
Okay, so does that help you?
Yes, because when I saw you doing the video, I saw the masses were different, but they all looked like the same size. So I was just wondering if we had to keep the same.
No, and I also used more than one potato, right? Because I had 30 pieces of potato. There was no way I was cutting 30 pieces of potato out of one potato. It took 2 potatoes to get all those little pieces cut out of it. Okay, let's get to the second one. If we decide to do concentration gradient, how would we control the amount of salt or sugar in each beaker? Well, that's kind of up to you. What I would do, because this is an experiment you designed, what I would do is I would put one beaker, or in your case, probably a jar or a pan or a bowl, whatever you want to use. And I would measure out, if you've got measuring cups at home, I would measure out 100% of whatever. So let's say you put 100 milliliters. We have measuring cups that actually measure in milliliters, metric units, and you want to use metric units. And if you have cups, use that cup and convert that to metric units. You can do an online converter. It's really simple. And then I'd have one that was 100% water. I'd have another one, say it would be 95 milliliters water and 5 milliliters of sugar or salt. So that's 95% water, 5% solute. Then I would go 90% water, 10% solute. Then I would go 15% water, or 15% solute, and 85% water. I have on the website a little practice virtual lab, and I'll refer back to that shows you kind of how to do that. Let me go to it. And I'll come back to this document in a second. So if you go back here, you can see this is a practice lab for using concentration gradient. I think that's what most of you guys are doing. I think I was talking to Janaya. I think it was Janaya. It was you last night I was talking to, right, Janaya Johnson? I think it was you. Are you here? I think this is your period, but anyway, I think that's what she was using. She may be in 3rd period, but you could just click on this link and it takes you through a whole virtual run through of how to do it. Of course, they're not using potatoes, they're using something else, but you just go through here and you can see how, if you're going to use concentration gradient, how you should do it. It's super, super straightforward. And a lot of people are using that. This little animation kind of gives you an idea of why the concentration gradient matters. You guys have already seen this. These would be your solutes on the outside. This would be inside the potato potentially, but water is going to try to go to those solutes. And actually inside the potato is not entirely true. Inside your potato, there's going to be some solutes. There's going to have to be, because they want to attract water. So they have to have solutes inside, because when it rains, you want the water to go inside the plant. So salt, roots tend to be saltier than the rest of the plant. But you can see the point that water is going to try to get out of those roots, of those little squares of potatoes, if you have a lot of salt. Those salt all comes by here and and you can see these are all little sodium particles and chlorine particles, and water loves to gets around them. Water loves to get around it, and they stick to it. And when they do, it decreases the concentration of water on this side, and they all are attracted to the solution that you put around them. Unless it's pure water. If it's pure water, water is going to rush into those potatoes because there's obviously some salt in a potato. One of the reasons we love to eat potatoes and roots, they taste delicious. That was whose question? Whose question was that? Try to chime in, because I need to know if I took care of your question. Okie doke. remain anonymous. So 3, exactly how long are the potatoes meant to stay in the bath? You decide. I put in there an hour. I will tell you this, if you let them stay in there for 24 hours, what do you think is going to happen? If I put potatoes in there for 1 hour, what do you think happens if I put them in there for 24 hours? What do you think would potentially happen?
I mean, they could take in so much water that they're not fully submerged anymore.
Yeah, they could take in so much water that they actually all equal about the same. They could all kind of equal out, and that would be a real big problem. You're looking for percent change kind of over time. So time is going to be something that we're going to keep constant. And if I were just to let them just go all day long, yeah, they could all get super saturated, and your results would be terrible. It really wouldn't speak to how quickly something is happening. So some of you guys may not want to use percent change. You might not want to use rate, and that's up to you. That's up to you. You can calculate rate if you wanted to use something other than percent change. So this is up to you. This is your design. This is where you guys get a little more liberty and get to have some fun on your own, and think about how you would do this yourself. Are the potatoes meant to be submerged in the water or just placed in? Yeah, they're meant to be submerged. They're meant to be submerged, and they need to all be in the water. That way you have the entire surface under the water, so osmosis can take place all around it. You saw that was almost a problem for me on my largest pieces. And I couldn't cut any greater than 2 centimeters. I'm assuming we would use chi-squared. No, I wouldn't use chi-square test. I don't know what the expected value is. We only use chi-square if we have an expected value. I don't know what my expected value is. There is no expectation. So I wouldn't use chi-square. I guess you might potentially, I guess if you compared it to whatever the control group is, but we're not going to use chi-square. I'll show you what you're going to use in a moment. Do the potatoes need to be the exact size inch by inch? No, we're not using inches. We're using metric units. And it depends. So some people are going to be using, actually, hold on. What are my 3 variables for changing the rate of osmosis? What are my 3 variables that I could use? Let's start there. You guys going to drop it in the chat? Not talk. You guys realize that I'm isolated here. I can't talk to you guys, and I want you guys to say something to me. Okay, good job, Turner. You said temperature. I need 2 more. Temperature is 1 variable that you could use. What's another variable that we could use? Temperature is a variable. Concentration gradient, surface area to volume ratios. Yes, thank you. You guys put these out for everybody. You're sharing it. You're giving them to me separately, or not separately, but privately. Yeah, these are all the things that you could use. You're right. So if I use temperature, they all need to be the same size, and they all need to have the same concentration that they're being subjected to. So if I were using temperature, which I would really try to get you guys to avoid, I don't know how you would control that. You'd have to have multiple beakers in multiple temperatures, and you'd have to be controlling that temperature for an hour. And I don't know how you would do that unless you've got some really good not scales, but hot plates. And so I'd try to avoid that one. Surface area to volume ratio, if that's your independent variable, the solutions all have to have the same concentration of water. I would recommend they're all 100% water, and you don't add any change the concentration gradient, because you can't have but one independent variable. Everything else has to be constant. Or if you use concentration gradients, they all have to be the same size. You can't have multiple sizes. So I couldn't have like 1 centimeter cube potatoes and 10% salt, and 2 centimeter cube potatoes and, I don't know, 5% salt. It wouldn't make any sense. I wouldn't know what was having the effect. So do they need to be exact same size? If you're using concentration gradients, they do. But I also wouldn't use inches. We don't use inches in science. We use metric units. So use the metric side of the ruler. And I'll show you how to take that result. I posted a video of how to actually take the result. All right, this is your chance to ask any more questions. We haven't hit the 15-minute mark yet. I've got 2 more minutes to take questions from you guys. Okie dokie. Well, I'm going to, okay. Probably not, Kate. So that's, if you have a scale that's measuring in whole numbers, it probably isn't worth using it because it's not sensitive enough. You're going to have changes that are going to be smaller that you than that you would lose if you were measuring in whole numbers. I would recommend measuring the size of them. And to try to keep track of them, you saw, what did I do to keep track of each one of my potatoes? Because that's what I was wondering. It's like, how am I going to keep track of all these potatoes? Guys, y'all, you please speak up, man. I don't want to be the only person, only voice I hear. What did I do to keep track of all my potatoes?
You stuck pins in them and then numbered them with tape. Yeah,
I had little flags. It's like little flag. They're all little independent pieces of potato. Thank you, sweetheart. Let's see, to clarify, if we're doing size, what is our independent variable? Depends on what you choose. Are you talking about keeping them the same size, or are you talking about keeping using different sizes? That question that just got typed is a little ambiguous. Do you mean this last question on question 8? Do you mean that they're different sizes? Or do you mean they're the same? Okay, different sizes. Well, then that is going to be your independent variable, the change in surface area to volume ratio. As you get smaller, your surface area to volume ratio increases. So your independent variable is going to be the different sizes, which is in effect measuring surface area to volume ratios as your independent variable. And the bigger you get, your surface area to volume ratio decreases, which is going to also decrease your rate of diffusion. Diffusion is going to slow down. The bigger you get, the harder it is for diffusion to take place, which is why our cells are small. Okay, ooh, I like your hat, Kate. Nice. There's some crazy hat day. I like it. Dig it. Okay, so we're going to play with data for a minute. So we're going to look at tidy data. How to keep our data tidy. I want to point out something on the website first. So I want to go here. I've got some hints and tips for you guys. And anytime you get stuck using data, hold on. Anytime you get stuck, whenever you're, using Excel and trying to manipulate your data with Excel, don't freak out about it. You can just Google these things and find the answers to this really quick. You guys are lucky that you have the internet just to look this up. So if I want to use in Excel, if I want to use percent change, and I'm insisting that you guys use percent change unless you use rate. If you want to calculate rate, you can look up the formula for calculating rate in Excel. It's simple to do. It's not a big deal. But I actually put it here. There's a formula for it. And one of you guys I'm going to ask one of you guys to read this out to me in just a moment. I'm going to open up my Excel spreadsheet and I'm going to show you the results from my lab. I'm not posting them because this is my data. You're going to generate your own data, but this is the formula. So this is practice, and in a moment, you're going to open this, and this is a separate set of data, and you're going to open it, and you're going to use it, and everybody's going to make a graph, and you're going to calculate the p-value. You're going to all text me the p-value. So watch what I do, and you're going to do it as well, and you're going to send me your p-values in just a moment, but we're going to be using Data Classroom. So I'm going to drop this. Just know this is where I'm getting this. One of you guys is going to read this out to me in just a moment. And you're going to have to do the same thing. So do really try to pay attention to this. So it will be very helpful. I will not be able to see your chats when you're chatting to me while I am looking at the spreadsheet. I'm going to get the spreadsheet up. There we go. I'm going to make this larger so you guys can see it. Make it big, big and ugly. And I've had a bunch of kids from last year that have said, oh my God, Mr. Pope, thank you for teaching me Excel because I have been using that all semester long and they just assume I know it. You're right, they will assume you know how to do this in college. So this is my data, and there's a couple of features about this. We're going to keep our data tidy. This is something that I want you guys to understand. You've got to keep straight. You notice I have all my data in columns. It is all in columns. So my left column is length of one side. So this is going to be size is my independent variable. Surface area to volume is my independent variable. I keep my independent variables all in the same column. This will not work unless you do this. And some people had trouble on the IAs because they did not do this. This will be your independent variable. And you'll see here's my 1, here's my 1.5 cubes, here's my 2. This will make your life so easy. And you only have to make one calculation one time, and there's a trick I'll show you. This is my initial mass. Now remember, I took mass. I was taking mass because I had a scale. You'll have to, what might take you a little longer because you're going to have to measure them. Now you have to keep up with them. The one great thing about you actually might not have to keep up with them because if you measure them all out and just realize that, yeah, you guys don't have to worry about keeping up with little flags unless you're using a scale, because all you have to do is just measure the change in size. So this is my initial mass, which is pretty close. And this is my final mass. Now, how do I calculate percent change? Well, Excel is a giant calculator. So the first thing you have to do is type in an equal sign. So equals. Now I need somebody to read me the formula for percent change. So I'm going to go to somebody. Let's see, who do I want to read this to me? The most beautiful child in the world is not here. That's my daughter. It's her birthday yesterday. And that song you heard earlier was okay, David Daniel. I want to hear David Daniel. Oh, I love your crazy hat dance. Love it, David. David, can you give me the formula for percent change on Excel? It's on it's on our class page.
Where is it?
It's on our class page. It's on today's lesson, Osmosis, October 29th. And it says practice data. Or something to that effect. I wrote the formula there. It's right there on the front. I'll switch off. I'll show you where it is. I'll go back. Daniel, you're looking right here. This is practice. You will generate your own data. You cannot use this data for your lab, but there is a formula here. And I want the formula for Excel. I want to make sure that people are going to see it and use it. So I'm going back to my spreadsheet, and you're going to tell me, what do I type in here? Okay, thank you, David. Except there's a real problem with the one. You gave me the formula, the general formula. What's the formula for Excel? What's the formula for Excel? It's a little different. If you use the formula, that's it. Now you guys, please take a look at the chat and you'll see that this is going to be important. Now watch how I do this, and then you in a moment are going to do this yourself. Now, the formula, you have to use order of operations. So I'm going to put in parentheses, and then I need to do initial, and your eyes need to be on the screen. I'm looking at some of you guys that have your cameras on. They need to be on the screen. Watch what I'm going to do. This is a shortcut. So initial, and what I'll do is I'll click the cell, click, and you see it highlights the cell, B2. And then minus my initial. You'll see the little squiggly lines go off of that cell. Click B, because this is my final, this is B3, and then encapsulate it, you put your parentheses, and then I'm going to divide by my initial. So it's going to be initial minus final, and all it really cares about is just the difference in these two. Initial minus final divided by initial again. I think, let me go back and look because the formula is kind of wonky. It's a little different. I'm going to rely on David's help here. Let me see. It is initial. I'm going to make sure. So I click back in here, divided by initial. And then the times for multiply, that function is an asterisk. And you have to put negative 100. And then you hit enter. Boom. So that's a 13% change. Quick and easy. Now here's the trick. You do this and you only have to do that one time. See this little box? This little box in the corner? Hover, and then this little plus sign, my little cursor, that's this big wide plus sign, will narrow to a solid, X. It's not hollow, it's not white in the middle. It goes to a solid X or a solid cross. Just drag it down. Done. You just calculated percent change for every one of your trials. Does anybody need me to do that again? Because you're about to do it yourself. Okay, roger that. I'll do it one more time. Those of you guys that are looking at your phones, you want to make sure that you're looking at me. All right, so I'm going to do it one more time. I click inside. I put my equal sign, parentheses, and then David put my formula over here. You can look at it again in a moment. When you open yours, you're going to go initial. So you click on the cell, click B2. That's my initial number for this trial, minus C3, not B3. I was saying B3, but yeah, these are my columns. So remember, you're going in columns. You're pairing your data in columns to B3, and that's, or excuse me, not B3, sorry, C2, but this is initial minus final, parentheses, divided by, which is easy. Now, what's going to be a little different here is going to be divided by the initial, and then you have to use, it's not an X from multiplication, it's an asterisk. So asterisk and negative 100, where the normal formula would just be times 100. You have to use negative 100 and then hit enter. Done. And then if you want to do it for all of them, I've only done it once. I'm going to do it 30 times in half a second. Bam. Solved. All of it. All the data calculated in one fell swoop. It took 1 minute to do that whole thing. Less than a minute. So now what do? Well, I need to save this. So let me save it. And you'll do this in a moment. It's going to be your turn to do this in a moment. So I'm going to save it. I'm going to call this surface area to volume 1A, because you guys are 1A. I'll save this. I'm done with this data. Now, what do I do with this? Well, I want to analyze it. All right, that's the first step to analysis, but I want to analyze it. So let's see if we can go. I'm going to go to our course. I'm going to go to our class. I think the library is where I keep the data classroom link. There's a link to data classroom. So I open data classroom, and then we're going to start analyzing data. So go to data classroom. I've got 3 functions here. I'm going to upload. I'm going to use mine from a spreadsheet. So I'm going to upload it. In a moment, when you guys do this, you'll do it from a Google Drive. You'll do it from Google Drive. I'm going to do it just from my computer. But I have Excel. If you have Excel at home, you can download it and use it in Excel. I need to choose a file. So I'm going to name this surface area to volume A. I'm going to select a class. This is your class. I'll share this with you. And then I'm going to choose the data. So let me go to cell processes. Where I think I saved that. I think it was actually AP Bio, old AP Bio. Let's see. Cell processes. Got a lot of files in here. Oh, where did I save that file? Hold on a second. Hold on, I gotta see where I saved that file. Get my chat out of the way, get Chloe's head out of the way. So this, I saved this. Save. Documents assignments, okay. So back. I had it under assignments. There it is. So now I save it, and it's going to open up to a beautiful data table. So let's take a look at what our data table looks like. Now, when you look at this, when you guys upload this, you're going to have an issue. You're going to be, I can already tell you there's going to be a couple of people that are going to probably give me a call like, I can't figure out how to do this. Pay really close attention. I still have my data from my initial and my final. We're not measuring this. These are not my dependent variables. My dependent variable is the percent change. These are just calculations that I have. I'm not going to deal with those. These are just measurements I took. This is the actual calculation, excuse me. So I want to change this. This is my independent variable. So what kind of data is this?
Oh, wait, right now on your screen, we still see the Excel spreadsheet.
Oh, you do? Thank you. Thank you, thank you, thank you. So once I'm gonna go back. I want to show you that again because you didn't see it, and that's terrible. So in order, can you see Data Classroom now?
Yes.
Okay, so you're gonna upload. You have options. You have options that you can use. I'm gonna use the upload from my computer option. So because I'm using Excel, I'm gonna select the file I just saved. And that is it right here. I call that volume in. Why, I don't know. I've got it. I'm going to call this surface area to volume point A so that you guys can see it. I'm going to save it to your class. You guys should be able to review this yourself, see how I did it. But you're going to do it again in a moment. So once I have it, I'm going to click. I've got it. Everything's beautiful. Everything was working. So I'm going to upload it. Now remember, this initial and final, these are just raw data that you took. We're only analyzing the percent change. Chat. Okay, so don't try to upload yourself yet. Don't try to upload yourself yet. So just hold on a second. Just watch what I do, and then we've got to make sure that you guys are logging in with the correct email. So just hold on just a second. Don't do it yourself until you watch what I've done. What kind of data is this? Length. Is this, what kind of data? Is it an independent variable, dependent variable? What kind of data is this?
That'll be your control, right?
Yes, my independent variable. So is it categorical, numeric, sample, or info? It is my independent variable. What do we do? We did this last time. I choose what? Categorical, numeric, sample, info. What do I choose? Okay, thank you. There's some private chats that it's categorical. Yes, so it is categorical. And this is going to be my dependent variable. So I'm going to click that. So this is my IV. This is my DV. This is going to be numeric data. Now, all I want to do is I want to take a look and make this into a graph. So I'm going to come over here, click scatter plot again. We're going to use the same one, scatter plot. I'm going to show both. And I have all, this is the actual data from the lab that I conducted. So do you guys think this is significantly different or not? What do you guys think? Yes, no, maybe so. Just eyeball it.
It looks like 1.5 and 2 are probably going to be the same. One
probably, okay.
One might be statistically different, but they could skew the average downward.
You know what? I wonder why my 2 is ahead of my 2 of my 1.5. I got 1, 2, and 1.5. I wonder how did I have that ordered? It's really weird that it did that. Huh? That's strange. I don't know why it did that. That's really weird. Go back to my graph. You see how I did that? 1, 2, and 1.5? I really hate that. I'm so aggravated with it. Oh, well, what am I going to do? I'm actually going to, I want to connect that. You can see there's a bit of a, that's kind of weird, but you can see that there's definitely going to be a less of a change between 2 and 1.5. You would, this 1.5 should be here. I really don't know why it's doing that. It's so weird. Oh well, what can I say? I'll get rid of that connect the dots. But in order to find out if it is really significant or not, we're going to go ahead and put our error bars. Looks like these two may be actually the same. I agree. I think you're right. I think 2 and 1.5 may actually be not significantly different, but there's definitely a difference between 1 centimeter and 1.5 and 2. There's no doubt about that. A way to actually find that is you can run a hypothesis test. This is something I didn't show you before. Now, you can see it looks at your data and it decides for you what is a good test. This isn't a good test for chi-square. So if somebody asks me, what can we use chi-square? You can't, not for this particular data. It's not really appropriate. But what we could run is something called an ANOVA. And you have to put this on your IA this time. And it's going to calculate it for you. And what an ANOVA shows you is just, is this significantly different? And remember your p-value. So a p-value is really a probability value. So the probability of this one is 0.01%. So there is a 0.01% chance that there is not a significant difference. As an interpretation of this, let's just look at it real quick. So let me just ask somebody. Let's see, who can I actually see here? I can see Chloe. She's at the top of the list, right there at the top. Chloe, when you look at this, it says a p-value equal or means what? A p-value of 0.01 means what? The groups are the same or they're different?
They're different.
Yeah, they're different. And when we're talking about difference, we're talking about literally statistically different. So if I have a p-value of 0.4 or 0.42, it says there's little to no indications that they might be different. And this is a good word stem for you for when you're writing your labs. It will tell you literally whatever your p-value is, doesn't matter what it is. Say when you do it, you come out with 0.11. That is not statistically different. It says there's some indications that groups might be different, but they're not. So I want everybody to use that data table I just made for you. It's on Schoology, and I want you to fetch it. Now, when you do this, you're going to fetch it, and I need everybody to text me privately what is their p-value. And then I may ask you to show me your graph. And we've got 15 minutes for you guys to do this. 15 minutes. And again, where you find this, I'll go back to the website, go back to Schoology and make sure that you guys can see this. When you go back to Schoology, you click here. You have to do exactly what I did. Now, I've got the in directions for you right here. This is just for practice. You're going to upload your own data, and you're going to be using Sheets, Google Sheets, and you just copy and paste that link where it says fetch. There's where I uploaded mine, you use fetch. And I'm going to give you guys, say, I got a little less time. I actually have 13 minutes for you guys to do this. It doesn't take that long. And I will go to, I'm going to put you in breakout rooms to do this, and I'll bounce through those breakout rooms. You need to talk and help each other. Talk and help each other.
There isn't like a link attached to it.
Attached to what?
To the practice, generating your own data.
Right here, if I click that, oh, it opens up for me. Yeah, you can, some of you guys are saying that, yeah, you can message me on Remind. Do you see it now, Chloe? All right. I'm gonna drop into these breakout rooms so people can help each other, but I'm gonna go to your breakout room and you're gonna share your screen and show me what you're seeing. So hold tight and I'll come in there and help you. Okay. Where's Chloe? All right, Chloe.
So like when I open that assignment,
Well, share,
there
you
is
can
no.
share your screen. You should be able to share.
Okay.
Are you able to share your screen?
It says I can't share my screen.
All right, I'm gonna leave room and make a change, and maybe I'll be able. All right, you should be able to share your screen now. You should be able to share your screen now. Awesome. Okay. Huh. I don't see anything on. Go to my document. Click my document. There it is. You got it. So now you got to calculate percent change using that formula. Do you want me to help you walk through that or not? Or you got friends?
I think I'm good.
Okay, I'm gonna go check another group. So you guys share your screen with me if you need some help. You can just, everybody has the ability to share their screen. One of you guys choose to share your screen and show me what you're working on. How about LeVar? LeVar, share your screen. You just go down where it says share screen and share with me. Show me what you're working on.
Okay.
Let me see.
It says host disabled participant screen sharing. Okay.
No, I didn't.
That's what it said for me. I press share screen.
Really? One of you other guys try. Oh, Dev, you try. What happened?
It's telling me the same thing.
Really suck. All right, I'm gonna go change some settings. I'll be back. Goodness. Okie doke. So have you guys been able to get this uploaded into Data Classroom yet?
We're uploading the practice spreadsheet, right? I was.
Yep. Do what?
Okay. I was in the bathroom, so I didn't know what we were doing.
Oh my God. Can you share your screen? Do y'all have the ability to do that?
Yeah, I can share my screen.
Yep. All right. Share your screen, work you all the way through it. You've already calculated percent change. Make sure everybody can continue. And I'm going to go bounce into another room. You guys have the ability to share your screen. So let's go to Gavin. Gavin, share your screen with me real quick. Let's see what you're up to.
Sorry, sir. What'd you say?
Share your screen so I can see how you're doing.
My data? I'm gonna be completely honest with you. I have not done my lab yet. I'm trying.
I'm not asking you. I'm talking about the practice, dude.
The practice lab?
That's what we're all doing. We're practicing the data right now.
Oh, I thought you wanted us to do it.
No,
Oh.
Johnson, can you share your screen for the practice data?
I'm so sorry, sir.
Apologize to your classmates, not me. They're the ones that you guys rely on each other. Johnson, see if you can share your screen. That can help. I've been able to go to other groups and help.
I use my other computer to look up stuff since it loads slow when I'm on a Zoom call.
Okay, so we'll go to Randy. Randy. I have to bring you back in 5 minutes.
Can you help me with finding the percent change? So
I can, but you got to share your screen with me. You got to share your screen with me. You go down to screen share and I can see what you're doing. Get over. Okay, can I help you with, okay, so first thing, you got to put an equal sign. So go to percent change. Whoa, what happened? You want to reverse whatever you just did, go back. See the back button over in the top left corner where it says undo? It's under, there's like little buttons right, there you go, undo. You have to undo until you get back to the original. Keep going until you get all the way back to the original. Should have a header at the top where it says, you know. Is that the original? Okay. All right, then click on there, put equals. You got to start out with the equal sign. And then parentheses. And then click click over in B2. You click on the 10. Click on the 10. And then minus. And then click on the C2. There you go. Parentheses divided by. So that's that /. And then you click on initial again. So that would be B2. Excellent. And then do asterisk. Negative 100, not 100, but negative 100. And then enter. Just click enter. Boom, 30%. That's your change, 30%. And you can see that, you know, going from 10 to 13, that is a 30% difference. Now go click on 30 again. D2, click on D2. Okay, you see that little box? Hover your cursor right over that little box in the corner. Yep, and then drag that all the way down, all your data. Boom, hit enter. Yeah, you did it. You calculated all your percent change. Oh, that's awesome. Now, go to, you got to save it, and then, or you can actually copy that link, but save that wherever you save your files, and you'll upload that into Data Classroom.
Thank you.
What's that?
I said thank you.
Okay, you're welcome. On everyone. Okay, some of you guys only had a few of you guys finish that. That's all right.
Mr. Pope,
Yeah, who is that? Is that Diana?
we don't, yes, we
Yeah.
don't have to download the spreadsheet, right? We can just fetch it.
Yeah, you can fetch it. You can fetch it. Yeah, you can fetch it. I just fetched it for this one. I just did it with this practice data. This is the practice data. Yours should look something like this. So I've only had 3 of you guys actually finish this and text me a picture. So I will open up an office hours today. I have office hours for freshmen, but I'll open up another office hours if you guys need some help with it at 4 o'clock. So I'll be here and I'll help you guys. But I want to show you what it could kind of look like. This is actual practice data I did. This is, and if you can't get in to Data Classroom because some of you guys are saying your internet's slow, that's fine. You've got a couple of days. The first thing you need to do is run your experiment anyway. But this is, I actually went home and did this experiment. So I kept my size constant, and this is what I got. What I think is really cool here, what I think is fantastic, I love how this worked out, is check this out. So at what solute concentration was it isotonic? Remember, isotonic is where you have the same amount of solutes on the inside as the outside. So, and look, and my percent change, some gained mass, this is 0, some lost mass. So at 0 and 5, they both gained mass. Where does the intercept, where's intercept for 0? Right about there. So what do you think the solute concentration is inside of the potatoes? What do you think? And I'm assuming you guys can see this, yes? Yes, no, yeah. So what it intercepts at 0. So what would be that would be where it would be isotonic. I lost mass at 10% salt. I lost mass at, I gained mass at 5% salt. Where did I actually, where's that slope intercept? 0 is right here. So I should be, the potato concentration of solutes where it should not change mass at all should be about what?
9?
Don't text it to me privately. Yeah, 9. There was a bunch of you guys texting this to me privately behind the chat. Don't do that. Just hit what we got is about 9. Some of you guys are texting me on remind. Don't be scared to share this out. You guys are smart. Go ahead and say it. Yeah, it's probably around 8 to 9. I don't have that delineated here. I didn't test it. I would want to go back and test and put 8% salt and see if they stayed the same size. The ones that were in 15% salt, holy crud, they lost about 10% of their mass. If I want to find out what my p-value is, just to see if it's really as significant, I come over here and I click it. My p-value is, come on, buddy, are you going to tell me or not? Oh yeah, right here it is, 0.01. It is, so this was significantly different. Significantly different. Yep, so this is what you will need to do, and if you need some help, and you do need to text me, I want to see that, but I do have an exit ticket today. This counts as scholarly habits. It is for a grade, but it's only a scholarly habit grade. It's right here. You can see where it says exit ticket at the bottom of the page. Once you hit that exit ticket and it's closed, you are out today. You are out. It's only 3 questions. It is a scholarly habit grade. It's pretty straightforward. It's all about this. And you can go back and look at your answers when you're done. You can go back and look at your answers when you're done. I set it so you can go back and look at it. It's an exit ticket. And just open it up and go. I'm looking for you guys. Let's see who's found it so far.
You wanted us to send a picture of our graph to you
Yeah,
and remind
you're
me.
right. Yeah, and if you can't do it, I'll be here at 4 o'clock to help you. I'll open up a call at 4 o'clock. I have 9th graders today at 3, so I have to do that. If you can't do it, see me at 4. But do this exit ticket, and I'm taking attendance through this exit ticket. And it is for a grade, but it's only a scholarly habit grade. It's only 10% of your grade. So it's low, it is helpful. Oh, I'm in section 2. I need to go to section 1. Ta-da. I was wondering, so where is everybody? Good job, Carlos. Good job, George, Johnson, Labracadabra, Abel, Dev, Rosenbaum. Yeah, you guys found it. Good job. All right. When you're done, you can leave.